All right, well, welcome. I'm Steve Teixeira. I'm the Group Program Manager for Visual C++ at Microsoft here from the engineering team, and I'm happy to talk to you about debugging today. I'd like to thank you all for joining me in the tent. I wanted to be in the circus, and so I guess I get to tell my mom I'm both a programmer and a circus clown today. So I want to do one thing. I wanted to get a picture of you guys to send back to Redmond, if that's okay. Okay, so, all right, if you guys could just all go over there. You're not all fitting in the, okay, never mind. I think I can get you. Okay, so, dice queso. Well done. Okay. You had your eyes closed, sir. All right. That's good. I'm going to put that on my blog. I hope nobody minds. I'll have waivers for you to sign later for that. Okay, so let me press on here. This is what we're going to talk about today. A couple things. I want to first go over what you need to do to be prepared for debugging. In many ways, debugging is like mountain climbing. You don't just like wake up one morning and throw a sandwich and a piece of rope in your backpack and go climb a mountain, right? You think about it, you plan it, you figure it out so that when you actually get to the mountain, you're ready to do what you got to do. And debugging's a lot the same way, and we'll talk about how. I'll go over a lot of the things in the Visual C++ 2008 debugger. A lot of it's similar to 2005, a couple new things, but more than a feature-by-feature approach, I'm kind of taking a more holistic look at things, and also trying to give you little hidden tips from the engineering team, things like that. So even if you're an experienced debugger, I hope you'll pick up, a few tidbits here and there. That's my hope. We'll talk a little bit about working with crash dumps, why they're important, how do you get a crash dump, what the heck do you do with it when you got one, how does it help you, et cetera, et cetera. We'll talk a little bit about debugging managed code. I won't go deeply into managed code today, and I'll tell you why in a minute. But we're mostly focused on native code today. Following that, we'll do some hints and tips, and then wrap it up with some Q&A, and anything else you guys want to do or talk about, I'm totally open. I have the rest of the evening for you. All right, so this is what I expect you guys are. I expect you're kind of experienced software developers using C, C++. If you're like, been doing COBOL and you thought you'd like come into that C++ debugging session and just see what the whole thing's about, the COBOL conferences across town, this might not be the best place for you because we're going to be looking at, call stacks and disassembly windows and registers and that kind of thing. So hopefully that's the kind of thing that gets your blood pumping. There's no application size I'm really optimizing for here, so the things we're talking about should work for any kind of apps you're building. So it's not like if you, not if you have to debug SQL Server, or it's not stuff that scales nowhere beyond Hello World. It should be stuff that works for everybody. Some things not in this talk, so C#. Not going to talk about C# today. Not going to talk about remote debugging. Not going to talk about WinINext. This is actually an old deck because I am talking about giraffes today. But that's later in the thing. All right, so before I get into the debugging thing, I did want to just do one slide and talk to you about the Visual C++ product because I really want to make sure I'm getting the word out here. By the way, speaking of Visual C++ sessions, how many of you were in Ale Contenti's session just before this one? Okay, so you guys are the die-hard C++ guys. Right on, okay. I think it's either this one or the next one. There's another one tomorrow morning where he's going to talk about ribbon and that kind of stuff, so definitely good stuff to see. What we're really about on Visual C++, and this mission statement really explains it all. It's about providing world-class native tools while bridging to next-generation platforms. So what does that mean in terms of our priorities? It means our first priority as a product is enabling people to be successful on the native Windows platforms. There's no other programming language in Microsoft, no other team in Microsoft that focuses and owns the native code developer experience. And so we take that responsibility really seriously, and that's definitely our focus. Secondarily, however, while you might be doing native code development predominantly, but there's lots of cool stuff going on that's not necessarily in the native code world. And so we think it's really important that even if you're building this multi-million line application and you want to do this new thing, you're not going to rewrite that multi-million line investment in order to get to the new thing. What most people want to do is they want to use all their investment. Sometimes that's, for some companies, that's literally billions and billions of dollars, or what is that? That's like 3 or 4 euro today. I forgot the translation rate, but it's not good. So yeah, so some companies spend as much as 10 euro on developing an application. It's very exciting. But with all that investment, they don't want to just throw it away down the sink and new shiny object comes along and rewrite all that stuff. It's battle tested. It's been in the field for a long time. It's been in customers' hands. They want to take that core and they want to build stuff around it. So maybe it's, they want a nice shiny UI. They want to use WPF. Part of what we're going to do is help people interoperate what they've got with where they want to be. Okay, so that's on C++. Now I want to talk about, going back to my mountain climbing analogy, if what you wanted to do is get to the town on the other side of the mountain, there's probably a better way than climbing up the mountain and down it. And likewise, when you're writing code, the best way to debug is to not have that bug to begin with. That's like the most effective thing you could ever do. So I would be totally irresponsible if I didn't talk to you about how to not have to debug that bug that I'll talk to you about later. Which is, make sure the bugs don't happen. And there are a few things I have on here, and I'll go into various levels of detail here. So, first thing you got to do is you got to take advantage of what the compiler and the compiler and the libraries give to you. In a lot of cases, it's almost free. It's like as simple as adding an include or setting a define or turning on a compiler switch. Really easy to do from a development standpoint. Some of these things have various performance impacts, and I will touch on those. However, if you're building for debug mode, typically performance impact isn't that big a deal. Sometimes it is, but typically it's not. And so, just to go over a couple things. So one is heap leak detection. A lot of people don't even know that there is a leak detecting memory manager that's built into the C runtime, and that it's easy to get to, pound including crtdebug.h. And if you do that, you can get lots of cool stuff, like you'll get unallocated memory looking a certain way, and you'll get buffers around allocation regions, and you'll be able to, dump out what the CRT thinks are the current memory leaks, things like that. So it's actually really powerful. It doesn't perform well, so you don't want to use it in release code, but really powerful to use in debug mode code. The other thing is runtime checking, RTC, which checks for both buffer overruns. Again, there's a performance impact there, but you throw the compiler switch and you kind of forget about it, and then you'll get asserts, in the debugger when something goes wrong. Very easy and very simple to use, and I recommend it. Now we'll talk about stuff that you might use in both debug and release mode. And so these you have to think a little more deeply about, because sometimes performance is key, and so you've got to balance bugs and performance, or the potential for latent bugs to be introduced, and the need for high performance in your code. So one is the security features /GS, which does the stack guards around variables on the stack. And I'll actually talk about this one with a couple slides, because I think this is a particularly important one. When it, maybe not most, but many software bugs that have been in the field over the past few years can actually be traced back to this type of issue. Also, many security issues that have been in the field over the past few years can be traced back to this kind of issue that can be disabled. You can totally block that attack vector or that vulnerability or that bug by simply throwing the switch. Safe exception handling, safe SEH, is another switch you can throw. Essentially what that does is prevents your exceptions from getting unwound to a bad place, someone from hijacking your exception unwinding to go to some malware. So that's a great feature as well. There's the security enhanced CRT. How many folks are using the secure CRT today? Just a show of hands. Just curious. Handful of folks. And for those of you that aren't using it, was it not multi-platform? What's the reason? Shout it out. It won't hurt my feelings. Wasn't aware of it. Good. You've come to the right place, sir. Good. Okay, so we'll talk about that. This is basically, we did a thorough scrubbing of the C runtime. And we looked for all of these functions that can potentially overflow buffers, because many functions in the C runtime leave it incumbent upon the developer to know how big their buffers are and what they're passing to a function, whether it's memcopy or sprintf or whatever. What we've done is we've added a bunch of other functions by appending _s. So you'll find like memcopy _s or sprintf _s. Those typically take a few additional parameters Not always. Sometimes we have templatized versions that can statically determine the parameters, but mostly they take additional parameters, and you could say, hey, this is the size of my destination buffer. Don't overflow it. You know, such a simple thing, but it's really super handy for preventing those kinds of errors. And again, I'll show you what that looks like in the field. And there's also checked iterators on the C++ runtime. I've got a little demo that talks about that, but this is basically the idea of making sure that you can't go beyond the bounds of a particular container in the standard template library with an iterator. That one, there is a slight performance cost to pay, but I'll talk about that one in more detail. Static analysis is another thing. Anybody using static analysis? Fewer number. Static analysis is really cool. What it enables you to do is, it's kind of a lint type thing, but you just throw this compiler switch and then it analyzes your code and it tells you what it thinks is wrong with it. You can combine that with your own SAL annotation, SAL being kind of a language decoration scheme that we use for this, where you could say, hey, if you call this function, the caller has to check the return value. Or, hey, when you call this function, this parameter can't ever be null. You know, those kinds of things. And you can annotate up your code, and then it'll look at how your code is being used, and it'll tell you. And often it'll give you the code path to the error, so it's really handy. I'll show you that in a moment. Also, if you want to know how to use SAL, the CRT headers themselves, you know, all the functions in the C runtime are great examples of how to do that. And then finally, you know, one of the things, you know, C++ grew up from C, and C++ itself has been around for a very long time. So there's some old code out there. None of you have it, but like we have it at Microsoft. We have some old code that we have to worry about that uses these old patterns. And so, you know, things like manually allocating memory. Sometimes we have to do it, but usually we don't have to. It's just there because when we wrote that code, there wasn't a better way to do it. And today, it's really common to use some sort of a smart wrapper to encapsulate resources like memory or handles or whatever. You know, you know, resource acquisition is initialization pattern. And one of the things that I recommend you check out, if you got some time tomorrow at 9 a.m., Ollie Contenti and Kate Gregory. Ollie is a dev lead on the C++ libraries team, so he's the dev that's responsible for MFC and ATL and STL and all those things that we ship. And Kate is a regional director in our MVP community, and you know, one of our best community members. And they're going to talk TR1, C++ OX, all the new stuff coming out for C++, including shared pointer, which is the new standard for smart pointer, smart resource wrappers. That's in the C++ language. C++ OX, by the way, being the next standard version of C++, that's going to ship maybe in a couple of years. I think Herb Sutter, who's an architect on our team, he's also the secretary of the ISO committee. And he's trying to get it into 09 so it really can be C++ OX. But if it slips to, you know, 2010, we just make OX becomes a hex number. And then it'll be like C++ OA, and then we'll be fine. We're not worried about it. All right, so let's talk a little more detail about this buffer overrun stuff, because this is an important topic. So here's just a little simple piece of code. You got this function bar, calls this function foo. Foo has a local buffer, and then it uses sprintf to format that buffer. Okay, so foo calls bar. Bar's got this stack frame. When it makes the call, it puts its parameters on the stack. After the call, the return address gets put on the stack. Then you see the buff there. That's the local buffer that's declared inside of foo. Now what happens if you overflow this buffer? Sometimes these buffer overruns happen, you know, innocuously. There's just a coding problem in your software. Sometimes it's a security problem. Someone is maliciously trying to, you know, breach your software. Either way, it's bad news. Doesn't matter how it happened. It's just really bad news. Your software's not going to do what you want it to do. And in fact, in this case, you can see it overwrites the return address. And so what happens when you overwrite the return address? Well, when function foo says ret, it's going to look for that return address on the stack. And if it's been overwritten, it may jump into la-la land. Or if it's been overwritten maliciously, it may make some sort of a near jump to some malicious code somewhere else on the stack that, you know, does bad things using execution privileges of this program. So we don't like these things to happen. So /GS totally fixes this scenario. at least this one that I've laid out. So you got the same kind of thing. Foo calls bar, or bar calls foo. The difference is right after the return address on the stack, we place a cookie. And the cookie gets determined when the application starts up, so it's different every time the app runs. And after the cookie go the locals that are declared inside of foo. So then what happens is when sprintf does its bad thing, it not only overwrites the return address, but it also overwrites the cookie. And now, before returning, the runtime will check and see, hey, is the cookie still valid? In this case, we're going to go, nope, cookie's not valid. And so we can detect an attack. And our mitigation here is we terminate the process, unplug it. Do not pass go, do not do anything else. Because the application's compromised, it's in an unsafe state, and you can't really safely do anything at this point other than terminate the process. All right, so that's how GS helps you there. Prevents a lot of bugs. And by the way, those are really hard to debug because your code ends up somewhere else and the call stack is only marginally helpful and very difficult to debug. So one other way that GS helps you is with shadow parameters. And so look at this function. This is very similar to the one I just showed you, except this time function foo takes a function pointer that gets called. So that's one of the parameters. And so we have the same kind of thing again. It pushes all those parameters on the stack, the function pointer, the size, the string, the return address gets put on the stack, and also we add that GS cookie. And then the local variables get put on the stack. And the other thing that we do is after all the local variables, we shadow the vulnerable parameters. In this case, we consider that function pointer a vulnerable parameter because it can be overwritten and it can be called through within the body of this function. So remember, the /GS cookie doesn't get looked at until the function is over with. It's done. In this case, that will be too late because if they overwrite this function pointer, they'll be able to call through it before this function terminates. And so we do a pretty nifty thing here. We call instead through the shadow parameter. We don't call through the address got passed on the stack. We call through the one that we shadowed underneath all the locals on the stack. And so even if the memcopy in this case does a bad thing, we still call the correct function, so no harm done there. Then when the function returns and right before ret is called, we check the GS cookie, we can see there's an attack, and we can shut down the process. So really super handy stuff. All right, next thing I want to talk about is checked iterators. And so checked iterators, I think I have a little project here I can show you really quickly. All right, so here's a very, very simple project. And can everybody in the back see my source code okay? Yes? Good? Okay. All right, so here's a simple project. One little main function. I've got a vector. I put an integer in it. I write that out to, to the console. And then I try and access beyond the limits of this iterator, or of this vector. So this, and again, this works with vectors, or if you're accessing via the bracket operator with the vector, or if you're using actual iterators, works the same way. This is just a simpler way to demonstrate. And so what this is going to do is, in debug mode, it's going to assert, or it's going to throw an exception in release mode. There is a cost here. There is a performance cost. Now, we enable secure SCL in every product that we ship at Microsoft. So we're pretty conscious about performance of our software, and still it's worth it to us to use safe iterators because it's that important. It's also very expensive to service software after you ship it. So if you kind of do the math from a financial standpoint, keeping out all these bugs is often worth a little bit of performance cost. Now, there could be some cases where you've got some super tight loop or something like that, and you just can't afford it. And maybe in a module like that, you would just disable it on a module by module basis. But by and large, that's not how these things are used. And so if I'm in release mode right now, so I can run this. And you could see POW, okay? It says that bad things happened, and if I break, I can look at my call stack here, and you could see, okay, well, this line of code caused a problem, and the CRT is telling me that I have an invalid parameter. Great. Okay, so through an exception. Very handy. And by the way, That's because I have this secure SCL defined. By default, it's turned on by default, so the default value is 1. If I set that to 0, different things happen in this case. Let me shut down this and then run it again. Oh, it just runs and shuts down. Yes. So it's a bug. In this case, it's a latent bug, and in this case, it's a harmless bug. But in the context of a larger program, that might not be a harmless bug. That might actually do something very, very bad. And so, including secure SCL is the difference between not knowing you have a bug and knowing it and being able to deal with it. Now, in debug mode, it's actually a little bit more useful. So if I look at this in debug mode, I actually get an assertion, and so I can trace back. And again, looking at the assertion, and I can get an even more useful error message, vector subscript out of range. So a little bit more helpful in debug mode, but still in release mode, it's goodness. If you need to shut it off in debug mode for whatever reason, you could simply define has iterator debugging 0, and that'll shut it off in debug mode. But something that's easy to do that's worth considering. And by the way, again, it is enabled by default. So if you're not doing any of that has iterator debugging, blah, blah, blah stuff, you're getting it. Okay. Okay, talk a little bit about static code analysis. Again, finds the errors in your code before you run it or deploy it. That's the time you want to find the errors before you run it, because then your test team doesn't have to find it, and certainly your customers don't have to find it. It checks for a whole broad swath of things, from stylistic issues to correctness in the code to security issues, a whole bunch of stuff. It is only in the team system version of Visual Studio, so it's in the expensive version of Visual Studio. It's turned off by default, and the reason why it's not enabled by default is because it does slow down the compiler. In fact, what happens behind the scenes is the front end of the compiler makes 2 passes. It makes one pass to do analysis, and it does another pass to build trees to pass to the back end. And so you will see some performance costs there. Now, I can show you a little bit of what it means to do static analysis and what kinds of things it'll do for you. All right, so I've got another simple project here. I wrote this little function called calculate square root, calc square root. And what it does is, it takes a pointer to a double, returns a pointer to a double, and it's totally arbitrary, and it's not like real world code, but it kind of best demonstrated what I wanted to show. And in this case, what I wanted to show is that the number that's being passed in, the pointer to the double, can't be null. And so you could see I'm using this attribute here, pre-attribute, and it says null equals SA no. And if you want to find out, again, the CRT has a lot of this lingo in it if you want to see this stuff in action. But there are 2 things that you need to do to your project to be able to use these attributes. One is to #include source annotations.h. And the other, if you don't want to fully qualify all the namespaces, is just use the VC attributes namespace. Those are the 2 things you want to do. Okay. So I'm doing that. The other thing I'm doing here, I thought I would demonstrate how static analysis helps you. Even if you don't want to do SAL or anything, you just turn it on. Well, since we have static analysis and we SAL annotate all of our libraries, when you use our libraries, we can give you helpful hints like you did something wrong, go fix it. So in this case, there's something potentially wrong. Anybody know what's wrong in this call malloc function? I don't check the return of malloc. Does everybody here check the return value of malloc every time we're new? Good. Blue ribbons for all of you guys. That's good. We enforce that with static analysis, or we at least tell you that you should be doing it. We don't treat it as an error. We treat it as a warning. And for those of you that, I just threw water on my computer. That can't be good. For those of you that did not raise your hand, you can count me among you. I don't always do that, but then I don't write code that goes into the product, so I don't have to. I write the code that we show up here. All right, so let me just make sure static analysis is first I'm going to run with it disabled here. So I'm going to go to code analysis, general, enable code analysis for C, C++ on the build. And I'm going to leave it at no. So let's just build this guy and see what happens. Okay, rebuild solution. Okay, it couldn't incremental link. I think I can get over that. All right, other than that, there's no problem with my build. So now let me just go ahead and flip that switch back on here. Yes, /analyze me. Okay, and so now that we're turned on, I'll rebuild. Okay, it's complaining about my precompiled header, which is an interesting thing. Did I mention I have a pre-release build of Orcus? I don't think I mentioned that from the beginning. So let's see here. Let me, precompiled headers. Okay, they're turned off, which is interesting. So here's what I'm going to try. I'm going to turn on use precompiled headers, and then I'm going to try and turn them off again. I'm going to fool the compiler. Do you think? Think it'll work? I'm kind of doubtful myself. Hey, that worked. Cool. All right. So I did get this error on malloc telling me that, hey, I'm potentially dereferencing a null pointer here. That's a really cool error. And then for some reason, it did not give me the second error on calc square. Oh, of course, because there is no error. But let me do this. Let me just go ahead and explicitly pass null and see what it does for me. Ah, there we go. Argument 1 might be 0. And this, what does it say? This does not adhere to the function specification. So it's very, very stern wording on the compiler's part. Okay, so good. I'm glad I was able to tap dance my way around that one. So actually, the build I have here is kind of a Frankenstein build. It's a couple weeks old. We're very close to RTM for Orcus. It's a couple weeks old, and I have a newer set of libraries that have the Office ribbon thing and the TR1 stuff. So it's a little bit Frankenstein, and frankly, I'm happy I've gotten this far without major issues. So not looking a gift horse in the mouth, I'm going to move on. So writing debuggable code. Couple important things here. And this is, somewhat common sense stuff, but use ensure. Ensure is it's kind of like assert, except ensure, what ensure will do is if you're building for debug mode, it will assert. If you're building for release mode, it will throw. And so you've got the optimal behavior, whether or not you're in debug or release mode. And we're actually trying to migrate to using this pattern in our own source code. Assertions are great. Anytime you make an assumption, you should assert that assumption. When you're assuming something's a certain value, something's non-null, something is null, you should put an assertion in your code that says that that's the value. And so I would be very surprised if most people in the room didn't know the syntax of assert. I think I've got a little app here that I can just show you. So here we go. So ensure, for example, if I were to do code that looks like this, ensure 0, and I were to call this up front. Oh, my bad. I apologize. That looks less like PowerPoint. So if I were to do some code like this that looked like, ensure 0, meaning it's always going to either assert or throw. In this case, if I run it, hopefully the compiler still likes me after that. And you can see debug assertion failed. That's good. If I switch this guy to release mode, and there you go. Oh, that's an error on my class. So let's just keep running here. There we go. And so there's the throw. All right. A couple other things I want to point out here. Coming back to my source code. So whether you're using assert or ensure, this little 0 here, You can do anything you want in there that returns, true or false, basically, 1 or 0, or something and 0. But never put code in there that does something useful, right? Never put anything in there that has a side effect. You don't want that code to do useful things. What you want it to do is you want it to be a logical comparison. Compare this and this and let me know how it goes. You don't want to do things in there that have some kind of potential side effect. All right, so coming back over here, exceptions again, definitely more debuggable. You can catch the point of the first error, unlike if you're just handling H results or whatever. You might not get around to handle errors until later, and suddenly it's very difficult to find the root cause. If you've got a first chance exception, you know exactly where the root cause of the problem is. Building projects that are debuggable. So here are a few tips for building projects that are debuggable. One, for any build you ship to customers or any build that you expect to debug internally, archive the symbols for that build. Archive the symbol files, the PDBs. When you build retail, always build PDBs with retail versions. Older versions of Visual C++, that was not the default on retail. It would not build PDBs for you. Starting with, I think, 2005, it became the default. So now when you go to release mode, we will default to building PDBs for that release software. And use property sheets to keep your settings together. How many of you are using property sheets? If I can just ask. Only a handful of you. I just want to show you what property sheets look like. So if I look at the property manager, it's just a window in Visual Studio. I switched over here on my left-hand side, and I'm looking at the property manager. You can see that I've got a couple sets of property sheets here. And what these property sheets are is they're actually sets of project settings. So I can have these sets of project settings that exist independent of any particular project. And so in this case, I have property sheets to do add the core Windows libraries, to include Unicode support, to turn on whole program optimization. These are all project level settings, and I can add or remove these whole groups of settings en masse without going in and manually tweaking individual projects. And it's really, really handy to make sure that, in particular, you have like debug and release. The things that you don't want to change for debug and release mode don't change, so defines and compiler switches and things like that. Because guess what? When you have a define or a compiler switch that subtly doesn't match up, it can cause a lot of grief when you're trying to figure out what's broken. And so a couple more tips for building debuggable projects. Build a full setup for debug version. So that's what we do internally when we build Visual Studio. And Visual Studio is a big, big project. It's about 45 million lines of code. We build debug and release versions of the product, and our QA department QAs both debug and release. And we have our automation running against both as well. And so sometimes we get into situations where the cost you pay for that, in addition to the additional disk space and compile time, is sometimes you find things that only happen in debug builds or things that only happen in release builds, and you got to figure out why that is, and that can take a little time, but it's well worth it. So I highly recommend that. And then collect your crash dumps from customers. I will talk more about how you do that in a moment, but for now I'm just going to say that it's an important thing to do. All right, so now we'll get into the Visual C++ Debuggers Toolbox. These are all the different kind of debugger things that I want to talk about. So from breakpoints to watches and tooltips and E and C, the memory window, the immediate and command windows. By the way, does anybody know the difference between the immediate and the command window? He does. Okay, I need to ask you what it is after the session, because to tell the truth, I think they're a little bit interchangeable myself. But is that you back there, Gilles? Yeah, that's you. Okay, and then custom visualizers, AutoEXP.dat, and the thread window. So we'll talk about all these things. All right, fun with breakpoints. So a whole bunch of things that you can do with breakpoints, and I'm going to grab my notes here because I'm going to cheat. Good. So I just want to go through a couple of interesting things with breakpoints here. Let me come out of here, and we'll come back to this project. And let's go ahead and comment this guy out so we don't make bad things happen. And I'm just going to set a breakpoint right up here at the beginning of this thing. Okay. Ignore the man behind the curtain there. That's just a bad breakpoint I have. So I'm viewing breakpoints. I imagine everybody in this room has seen the breakpoint window, has set a breakpoint, has clicked and created the little red dot. And probably most people here have looked at things like this local menu and kind of maybe have kind of used it. I want to talk about what some of these things mean and what you do with them. So the counts. Counts very simply say when the breakpoint is hit, you can always break. You can break when the hit count is equal to or a multiple of this, or when it's greater than or equal to this. And this is really handy. For example, if you have some code where maybe you have a loop that executes 1,000,000 times, and it's the 1,000,000 minus 1th time that actually exhibits the problem, you can set your breakpoint to say after 1,000,000 times break. And that way you don't have to hit F5 1,000,000 times, which makes your finger hurt. I learned that the hard way one day. So counts, pretty straightforward. The one thing that's maybe a little interesting is multiple of. So if you have like a bug that's occurring on some boundary, perhaps on an array, or some multiple on an array, it's useful for that situation. Okay. And filters. Another interesting feature of the debugger. So if we take a look at this thing and look at filter. So filters are really great for multi-process and multi-threaded debugging. A lot of times, let's say you're writing some server software, let's say you're writing a web server, right? So a web server can have many, many threads executing the exact same code path at any one time. It's a typical server scenario, right? Lots of threads doing the same thing. But maybe it's like that one thread over there and not those threads over there that's causing the problem. So what do you do? If you set a breakpoint on this function, it's going to get hit a zillion times when all these threads hit. Well, you can filter it for thread ID equals 1, 2, 3, or thread name equals 1, 2, 3. So where do you get these thread names and thread IDs? We actually have a window for that, the threads window. And so I'll talk more detail about the threads window, but right now I just want to point out that you can get things like the ID and the name. And so when you find the thread that's the problem, you can set a filter for that, and it really helps you debug in that situation. All right, so now let's look at some of the other cool things you can do with breakpoints, like conditions. So conditions, this is kind of like a little expression evaluator. And I got a couple bullets here on the slide, so I'll show it to you here. So you can do interesting things like you can look for, hey, am I in this instance of a class? And I'll show you how that works. Or, hey, is this byte on the stack equal to this? You can do some really interesting things. You can't do full expression evaluator stuff. You can't like call functions and that sort of thing. It's not made for that. It's really made to do logical comparisons. So how might we do that? Let's see. So let's, and I've got a ton of breakpoints here. Let me just get rid of them all. Okay. So I've got some code here that we'll ignore what this code does for a moment. I want to talk a little bit more about this code later. But the important thing about this code is that it's got 4 instances of the same class. And so if I set a breakpoint over here, looks like jar's not getting called. Let me break. Just going to move this line of code up here. Good. So sometimes helps if I'm in debug mode when I'm debugging. All right. Okay. So here we go. We'll set a breakpoint out over here, and then we'll run this thing. Okay. So again, F5, 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 again with the tired finger, right? How how can you avoid this kind of thing? So this is kind of a different scenario. Let's say you've got this situation where it's not really multiple threads that you're trying to bug, but let's say you have n instances of one class. But you know it's like this instance over here that when it calls that method of the class, something bad happens. So you want to set a breakpoint, but only for that instance of the class. So what I would do is I would come out here and I would change this breakpoint and add a condition to say something like, this is the address of P3. Well, let's evaluate that. Oh, I don't have P3 in this context because I'm in the wrong place. So let's first come back and set our breakpoint here. Oh yeah, again, tired finger. Okay, so we'll first set our breakpoint here so that we can actually get at the address of P3. Okay, so here's the address right here. I can copy that, and then I can come back up here and set a condition here. I don't need all that, although it's very handy information. It's not really what I need. Okay, now you can see that my little debug symbol turns into like a Swiss flag thing, and I can run this, and you can see that I've stopped here and stopped only once. So I stopped on that particular instance of the object. Okay, then we have data breakpoints. Data breakpoints are great when you have some global data that's getting corrupted. That's the typical bug that you sometimes stack data, but you've got some data that's being corrupted somewhere, and you don't really know why or how, but you need to go fix it. And so the way I might do that, so what I did here is I declared a global integer called, and it's set it equal to 42. And what's that? Oh, no, just trust me. I have a global integer, and it's really 42. Why do you really need me to prove that to you? Come on. There it is. See? I don't lie. I'm all about the truth here. So there it is. Global int is 42. And then I wrote some code over here that sets that global integer in this method that I don't know anything about. So let's see. Down in my code here, you could see I do a cout of that global integer. And I want to see what the value is. So I expect it to be 5, though. So the last thing outputted by this program should be the number 5. Just going to turn off these breakpoints and run this. And if I go over here, you could see that the last thing is, in fact, the number 5. And let me keep running. All right. So if I comment this out, my assumption is going to be, oh, okay, well, I set it equal to 42, so the last thing it's going to say must be 42, right? Because that's the thing I initialized it to. So now if I come here and it's -1, oh, that's bad. How did that happen? I didn't really want that to happen. Okay. So the way I might go about doing that is setting a data breakpoint. Best way to do it will be to set a breakpoint right up here. I can only do that when I'm running because that's the only time I have addresses to set data breakpoints on. The address of GI, 4 bytes, size of an int, sounds good. So when that address changes, go ahead and break. Aha, breakpoint was hit. Great, I can look at my call stack. I can see, oh, I see WinMain called jar, and jar, I can see this one line of code did it. Great. So that's what my data breakpoint does for me. There's also trace points. Trace points are really interesting because they're like breakpoints that let you do stuff. In fact, I think trace points are kind of a bad name for them because they imply that all they do is, give you information. And so let's take a quick look at how they work. Yes? This is not my data breakpoint. What I did is the reason why I set a breakpoint at the top of that function, which is the top of main, is because you can only set a data breakpoint when you're in debug mode, because otherwise there's no address that makes sense. And on Vista, it's much worse because Vista has that address randomization stuff in it. And so it used to be like when one run of the program, all the addresses would be the same as the other run of the program. Now that's couldn't be further from the truth. Every run, you get different addresses for everything. So that's what I was doing there. All right, so I was going to show you trace points. So I know, an interesting place to show you trace points, I've got a little code here. So this is a little piece of code, trace PT, and we move this up to the top so it gets called first. All right, trace PT. And this code basically doesn't do much useful. There's a thing that counts from 0 to less than 1,000, and then there's a thing that decrements from 1,001 on down, and then I just print out that number. And so when I run this thing, just to show you once again, oh, let me set my breakpoint at the end so you can see the window. There it is. So you can see that it indeed prints out, down to 1, and then some other stuff, some other functions print out stuff, but you can see that it does what it's intended to do. There's some cool tricks you can play with trace points. I'm just going to set a breakpoint up here, and I'm going to go to the disassembly window. Okay. How many of you use the disassembly window on a frequent basis? Oh, great. Lots of people. Cool. All right. So what this is showing me is the disassembly for my lines of C++ code. And so you can see, assigning J as one move operation, and this loop is another, and subtracting from J is another. And gosh, I found this bug that, for some reason, I don't want to be decrementing J. I found this bug, and I've proven to myself that I don't want to be decrementing J. That's what I need to do here. And so how can I do that? One way might be rely on edit and continue. I can comment out that J minus minus and hope that edit continue will kick in and it'll run. Another way to do it is to use a trace point. So I'm going to set a breakpoint right before this J minus minus thing here. And when hit, this brings up the trace point. So you can do a whole bunch of stuff with trace points. You can run a macro in the IDE. You can print out a message, and you can use a bunch of predefined expressions like star address and $sign address and $call stack, and that will print that out to the debug window, and those things are very useful. You can also do some interesting things. So let's play a little game here. Let's say we want to skip J minus minus, and I'm going to add some code here to reset the EIP. And the EIP I want to set it to is the instruction pointer that happens right after the J minus minus. So it's looking like, it's hard to read. I'm sure it's an eye chart from where you're sitting, but because it is for me and I'm standing right in front of the computer, 00449C49. All right. So what this should do is not only print a message like a trace point, but this code in here should cause a side effect that will actually move the instruction pointer and skip over that J minus minus instruction entirely. All right, so let's do that. Let's run this guy. There you go. So J is never getting decremented. It's going to print the same thing 1,000 times. All right, so we'll just stop debugging there. So silly debugger tricks, but yeah, great, encore. All right, so we'll run this one more time. Now remember, I set it to a raw memory address last time, and if I go back into my disassembly window, the addresses are different, I think. Let's see. Oh, it might not be in debug mode. Let's see here. So when hit 449C49. Oh, actually, it's the same. But I don't know if this is going to live. So let me just delete it and create a new one here. So on this thing, set a breakpoint. When it's hit, we'll say skipping J minus minus, and then we'll do an EIP equals 0x, and the address is 0044 9C49. There we go. You can set registers. I don't know. There might be some other things. You can grab information. The only thing I know, the only trick I know is to set registers. I'm sure there's more tricks you can play in here. I'm a one-trick pony. That's my trick. All right. So now if I run this thing, and there we go. All right. So that's trace points, or that's at least part of trace points. Another thing that I might show is what we call wildcard breakpoints. And wildcard breakpoints allow you to set a breakpoint using wildcard syntax so that you can say, like, break into any method of this class. And so what that would look like, for example, I have this class here called person and this method called shower. So I can bug, new breakpoint. I should be able to set a breakpoint at person : star, and then run my code. And let me get rid of these breakpoints. All right, and there we go. So first I've broken into the constructor, and if I F5 again, oh, I'm constructed a few of these. There we go. Then I'm going to break into the method calls, and I'll get a few of those as well. All right, so yes, absolutely. Yeah, you can combine all of these. So there's like this whole combinatoric thing you can do to get all of these things going at the same time. Absolutely. So yeah, you can have a condition and a filter and a count and et cetera, et cetera. And then, so breakpoint syntax for those hard to reach places. I'm running, I want to make sure I have time for some other stuff. So I want to just show you this syntax for hard to reach places. So you saw when I opened that breakpoint dialog and I typed in person : star. There's some other syntax I can use. For example, the syntax that lets me break, with this function, this source file in this module, and then with the condition. So I show at the bottom of this just a simple set a breakpoint in this CPP file on line 136. And you can do some interesting things, like if you've got, a common use of this is if you have a CPP file that's included in several different binaries. And it's like a bunch of DLLs in your project, for example. And you only see the bad behavior when that CPP file is used in one of those projects. Well, you can use this syntax to say only when it's used in this particular project should you break on this file. Only in this binary. So it's pretty handy. Okay, watches and tooltips. Moving right along. So watches, a couple things that are interesting about watches. Let me go to my watch window. And I got something weird in there. So I knew that. So let's set a breakpoint on this vector thing. Okay. So if we run this now, let's delete those, and let's go to my breakpoint, and let's delete these things and delete this thing. Aha. Now let's go. Okay. So I've set a breakpoint here. So how many of you knew that you could grab a variable here and drag it into the watch window? Oh, okay. I'm not challenging anybody. All right. So let's take this a little bit further then. Let's grab our global. So we'll take that and we'll drag that over here. how many of you knew that I could edit the value of something in the watch window? Wow. Okay. You guys are really on top of things. All right. How many of you knew I could format something as hex? All right, that was kind of boring. So there are a couple of other interesting things that you may not know. So let me take a look at this one here. And where's that other breakpoint? Okay, we'll get rid of you. So let's keep running. Okay, so this is another function I have where I have an array of 8 integers, and I just do a little funny pointer thing to get a pointer to those and emit that to the console. So if I'm to, for example, take a look at I2, whoops, helps if I select I2 first. There we go. Okay, it's a pointer to an integer, so naturally what I get is nothing until it's defined. There we go. An integer, right? Shows me the pointer value, then it shows me the integer that it points to. What if I want to see the whole array? Well, I know how big the array is. It's 8. So I can just do variable name, comma 8, and it knows that that's a pointer, and so it can show me the entire array. So that's a handy little trick. How many of you knew that? Okay. All right. Maybe I can try something else. Okay. What if I want to get a pointer to a location in the middle of the array? So like I want to get starting with the 4th element. I can do I2 plus 4, comma 4. And then I get 5, 6, 7, 8. How many of you knew that? Less of you. See, now I'm getting somewhere. Okay, good. So that's watches. Tooltips are interesting as well. So if I come over to my tooltips, I can get similar kind of stuff. So here we go. Here's my code. Here's my tooltip. I can look at this array. And I know the tooltips are probably going to be hard to see from the back of the room, but you could see each element of the array, so it's pretty cool. But did you know that even the tooltips are editable? Yeah, some of you knew that. So the tooltips are editable, which I thought was really cool when I figured that one out. The other interesting thing, and I think this is a new 2008 thing, you know how this tooltip gets in your way? If you just hold down the control key, it stops doing that. So it kind of grays out once you do that. That's kind of interesting, does a little transparency thing. And of course, yes, sir. Oh, if you're doing multi-monitor, you're getting your tooltip on the second screen? Yeah. Yeah, the control key is of no help to you if the tooltip's on the wrong screen, of course. Yeah, that sounds like a bug. We should fix that. I apologize for that. That's not good. Okay, and then many of you may know that in terms of the standard template libraries, as I have this vector and I want to push some stuff into it, I can look at this vector, and in fact, this vector appears like an integer or like an array for me, which is really useful. Couple magic keystrokes I want to tell you about. So when you get that tooltip, you can use a few keystrokes. Of course, up and down lets you navigate by element. Page up, page down, you can navigate by page if you have that much in the tooltip. You can do right and left to expand and collapse the tree view. F2 to edit the current line, so you can not have to touch the mouse at all. And Control does the ghost thing. That's pretty cool. Unless you're on multi-monitor, then the ghost thing isn't cool at all. So I have to thank Gilles for the great charts here. That was very useful, and I shamelessly stole them from you. But I thought, you know, all these different format things in one place, so if you guys want to grab this deck, you can actually get all these cool format specifiers. I'm not going to like go into all these. I do want to focus on a couple really, really cool ones, though, which are the last three to me in this one. So HR will actually convert an H result into the string that represents that H result. And WC will convert a window class into the string that represents that window class. And likewise with WM, showing you the string for that Windows message. So if you're debugging, particularly GUI Windows apps in the latter two cases, and if you're debugging COM code in the former case, really, really handy way to look at things in the watch window. Couple of other just interesting tidbits here in terms of looking at quad words and things like that. You can also look at pseudo registers. So you can, for example, look at the value of a register. If I want to watch, the value of EAX or something like that, I can go ahead and do that in the watch window. And in this case, it's 0. But all of that stuff. So I won't go into excruciating detail on these, but I do want to let you know that they're there to use. Okay, edit and continue. Edit and continue is really great when it works. But it doesn't always, unfortunately. And in particular, there are two scenarios where it never works. One is 64-bit, and one if you have any managed code in your C++ project. If those are the case, then edit and continue doesn't work for you. That's not something we're going to address in the Visual Studio 2008 release, but it is something that's on our list for the next major release. We're calling Visual Studio 10 right now, but it's sort of on tap to be addressed next time around. But edit and continue is very useful, so you can have a situation like this where, let's say I've got, I really need that help for somebody to just shout at me screen every time I get here. So edit and continue should kick in a scenario like this. I've got a breakpoint, and I went, oops, I commented out that line of code, and I shouldn't have. Let me go ahead and uncomment that line of code, and then keep running. And you can see down in the bottom right, it says edit and continue build started, and then it keeps on running. And so this is especially good for like the people that are customers that use edit and continue like crazy are game developers. Because for game developers, it's so hard for them to get to a repro case, and it takes such a long time that once they're able to reproduce the bug, they're like, hold on, man, I'm just reproducing this bug. I've got to be able to do as much as possible in this repro case. Give me edit, continue, give me everything I can to get maximum juice out of this repro case. And then once you edit too much, of course, then you lose the ability to edit and continue. There's kind of a threshold of what you can do, but you don't have to, like, every time you make a change, take forever to reproduce the problem. Okay, memory window, another slide I stole from my Microsoft France colleague. This one's great because I thought this was the perfect reference for looking at things in the memory window. So the memory window, you just set it to an address and it gives you a raw dump of what's in that address. But there are actually useful values. And a couple of these that show like, the bad food that the operating system uses, or unallocated heap, or boundaries around allocated heap. So there's all this interesting information you can get out of the memory window. Now, back in the day when I used to do a lot of COM development, when I was young and crazy, I found the memory window really useful because you can figure out like where vtables are. When that's interfaces or vtables in COM, and so you can go, oh, that's obviously bam, 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 a bunch of addresses that are real close to each other. That looks just like a vtable, and so you can get much interesting information out of the memory window. I won't bore you by showing you memory window stuff necessarily, but it's there and it's cool. All right, so immediate and command windows. Let me switch over. So a couple cool things you can do. Let me just talk to this slide really quick first. And so I like to call this the driver's seat for people of the anti-mouse coalition. You don't like using the mouse. I have some colleagues that would rather even not have a mouse on their desk. They want to just do everything from the keyboard, and that's fine. And that's kind of what the immediate window's for. And so, you can use it in several situations. So let me just go over here to the immediate window. You saw me use it once earlier. But you can do some interesting things like, for example, run pretty much any command that exists in the IDE. Well, not really pretty much, but actually any command that exists in the IDE. And it gives you this IntelliSense type thing. So if I type edit dot, and as I type, it kind of narrows down the search, open file. So I can, if I do this, oh, it's not available because I'm in the middle of debugging here, so let me shut this down. All right, so let's let's see here. Oh, won't let me do it. Very strange. Let me give it one more try before I, yeah, walk away shamefaced. Okay, it does do other things. Like, for example, hopefully this will work. If I use the question mark to say print, it's an alias for print. It's not called global underscore x, it's called global underscore I. Ah, there we go. So I can do print global underscore I, and it'll do that for me. I could even call a function from in here. So for example, let me find an innocuous function to call. Woo, that looks fairly innocuous. So I should be able to come down here and just come back to my window, type woo, and void. Yes, it called woo. And I think that function had some output. Yeah, so it outputted the number 1. So great. It does all that kind of stuff. I can also use NTSD commands, which are kind of, for those of you that are more kind of in the WinDebug world, that's your cockpit. There's a pointer here to a whole list of commands. I don't want to go into the depth of everything that it does, but I want to let you know it's there. The syntax, by the way, if you're going to do a command, is you start with a little forward pointer like this, and then you start getting IntelliSense. And then if you want to print something, it kind of goes with the question mark. All right, now this part is really interesting. This is what I wanted to get to. AutoEXP.dat. Who's edited their AutoEXP.dat? More of you than I expected. Wow, I was expecting like one person who works for Microsoft to raise their hand. So that's pretty impressive. So AutoEXP.bat is really cool, and I think I have a version open. So by the way, who does their development on Vista? Handful. So one thing to know when you're editing this file, it exists in a tree of program files, actually. I think, I put the location there, Common 7 packages debugger. So when you're editing this file, run Notepad in elevated mode. That's the way I got it to work. All right, so don't fear the text, I say. All right, let me bump up the volume on this text so we can actually read it. All right, so what I've done is I've got a little class here. Remember that little person class that I made earlier? I actually made this last night when I was really, really sleepy, so it's kind of dumb. But so I've got this person class, and it's got like first name, last name, age, smells, cool factor. I don't know what I was thinking, and their address. And then if they smell, you can call shower, and it makes them not stinky anymore. I don't know. So let me run this. Let me set a breakpoint like right here on this line. Let me run this guy. Okay, there we go. So if I look at P, it's kind of useful. You could see that I'm getting, first parameter, second parameter, third parameter. Then the tooltip thinks, well, I'm kind of out of space, and then it, gives you some ellipsis, and you can drop down, and you can drill infinitely into these things. So I can drill into address and country and postal code. So it's cool, but it's not necessarily what you want to see. And in fact, AutoEXP.dat is the thing that we use in order to do those cool STL visualizations so that you can make a vector look like an array. So what if I wanted to do something to this class? Well, in fact, that's what I did. So let me come over here and uncomment this line. And I'll just say that, I'm going to get rid of last name. So I'll say person equals name equals, age equals, from equals. And you can see the syntax that I'm using. I'm actually giving you my age in hexadecimal, because it looks better that way. And then the city that I'm from. And let me save this file. File save. There we go. Oh, I may not have run Notepad in elevated mode. Wouldn't that be bad? So let me come back here and just give it one more try. Close this instance so I don't get them mixed up. Okay, so I should, there it is. And let me come back over here. And I know it's hard to see right now, but it's actually not that key. Okay. Okay, saved, good. Okay, so there you go. There's your lesson in running Notepad in elevated mode. Come back and run it again. And now if I put my cursor on here, it doesn't work. Now, it was actually working for me earlier without restarting Visual Studio. I know you don't believe me, but it really was. Now, of course, it's not, and I take full responsibility for that, but be that as it may. All right, so let me just bring up VS again really quick and give this a quick try. So there we go. So now it says name, Steve, age is 24 from Redmond. So there we go. And nice and handy. You can do lots of interesting things in your autoexp.dat file. When you have a few free hours, you can go ahead and try and read through that file because it's pretty complicated and it's pretty long. But you could do interesting things like the visualizer I mentioned. You can also do things like execution control, for example, preventing yourself from stepping into certain classes or certain functions. Threads window, I promised I'd show you. Actually, I have a superior project for showing you the threads window, so let me close this. Yes? Is there a question? Oh, yeah, I will get you. I didn't forget about the screen this time. Okay, here's my project. Okay, so this is a Mandelbrot project that just draws a cool Mandelbrot thing on the screen. And it uses OpenMP, so it's, okay, this is a runtime version. So I should be able to render using runtime, hit this breakpoint, I should be able to go over to the threads window, and I can see the multiple threads that are going on. I can switch between these threads so I can see what the various threads are doing at any one time. I can use the UI to freeze or thaw the thread. I can switch between them. There's another little cool bit that the IDE shows me. Let's see if it'll show me here. You can't see it from here. If you have multiple threads that are close in proximity in your code, it'll show you a little blue and a little red thread, and then you can right-click on those and you can do different things on the thread, so it's pretty cool. You can also flag threads if you're interested in them, so let's say you have lots of them and you're only interested in a few, you can flag those, and then you can filter by threads you're interested in and threads you're not interested in. So that's handy. So crash dumps, I'm a little short on time, and for crash dumps, I would like to say one quick thing here. Let me close my... I just want to demonstrate one quick thing with crash dumps. So let me close this solution. So what I did for crash dumps is I created a little MFC project, and in this MFC project, let me grab my project here. Okay, there's my MFC project, and I've got two buttons. The two buttons, one of them does an infinite loop, and the other button dereferences null. And what I did for these is I ran these, built this in release mode, ran the project, and obviously they didn't do the right thing, right? One of them just kind of hangs forever, the other one dereferences null. And so when it does that, I'm able to go ahead and attach Visual Studio by saying attach to process. And then after attaching to the process, I can select the menu item to create a, it'll come off the debug menu, I believe, and to create a crash dump with that. And using that, it will generate a dump file. That dump file I can then load into Visual Studio by opening it as a project, and then I can look at the stack, I can look at the registers, I can get lots of interesting information from that. I just want to show you one dump file really quickly, and I'm going to show it to you in WinDBG. And the reason why I want to show it to you, let me open up a crash dump. The reason I want to show it to you in WinDBG is because WinDBG actually does something a little bit interesting. Let me go to Documents. Okay, so here's my dump that I took from dereferencing null. And so WinDBG does some interesting things. There's this cool feature called Bang Analyze. Oops. That gives you lots of fantastic information. And I don't have my symbols set up. Let me tell it where my symbols are. I have my symbols in. All right. So in this case, I've actually got the source code. So it's going to tell me exactly where the problem is in my crash dump because I can see the source code. I do want to say about symbols, and I'm short on time. So about symbols, any of you signed up on WinQual? A number of you. If you sell software to people, you should go to WinQual and sign up. What that will do is that will allow you, you know that dialogue you see when something crashes that says, hey, I'm sending this to Microsoft? We do collect that. We put them in buckets based on various heuristics like the code signature and the file version info. And if you register with us, we'll give you all your crash dumps. And as a result of that, you can go through, you can look at them, and you can, you can act on them and turn those around and get them to your customers. So a couple words on mixed code debugging before I close down. It's hard to do mixed code debugging. The debugger's a little bit slower. Doesn't always get stuff right. Whenever you can, do native debugging or manage debugging only. And there's settings inside of the debugger that you can use in a project setting to set it to native or managed. If you do need to do mixed debugging, or you need to do debugging that uses different versions of the CLR, I recommend you use WinDBG with the SOS extension. That's all simple. So I'm going to go like 30 seconds, top 10 things you need to do as a developer. 1, design for debuggability. We talked about that. 2, the call stack's your best friend. You can't find any kind of bug without knowing the call stack. Next, the code generator is almost never wrong. All of you blame the code generator once in your lives or twice in your lives or every day for something going wrong, but it's really quite good. It's very rare that we find a problem and the problem ends up being our code generator. Again, spend time narrowing down a repro case. It will really pay off. If you get these isolated solar flares, it's just very difficult to deal with. Debug into all your code. It's not about just my code. If you've got MFC sources or ATL sources or third-party libraries, you should be debugging into that source code as well. Set next statement, again, going back in time is difficult in debugging, so I showed you one technique for doing this by setting EIP. Data breakpoints, we talked about those. Those are great. People lie. Don't ever forget that people lie, and when somebody's been debugging a problem and they tell you what they found, it's probably not true. Verify it yourself. Collect your customer data, collect your crash dumps, and the number one thing is get your symbols. When you get a crash dump, if you don't have Microsoft symbols, you don't have your own symbols, the registers aren't going to be useful, variables aren't going to be useful, function names aren't going to be useful. Microsoft symbol server's out there, it's available to use, you should definitely use it. All right, so Q&A, I'll just hang out here. My deck has some additional resources if you want to grab this deck. A number of really great blogs, by the way, that you can get cool debugger tips from. Don't forget to fill out your survey, and I will bribe you to give me a good review. I'm not above that. And thank you.